Okay, lesson 1.2, solving multi-step equations. You can find the notes on page 10 of your student journal. So let's get started. What are we going to learn today? We're going to do multi-step linear equations. We're going to use inverse operations. We will then use some multi-step linear equations to solve real-life problems. So when we solve multi-step equations, we want to solve a multi-step equation by simplifying each side of the equation, if necessary, first, then using the inverse operations. So we're going to be looking for things like whether we need to do distributive property or if we have fractions or whatever we may have. So these may get a little more complicated, so just take your time and be sure to write down any questions that you may be having. Okay, so on page 10, we are going to just do a few of them. You can see I've kind of jumped around here. We're going to do 1, 2, 5, and 6. So let's get started. For number 1, it's a simple two-step equation. There is nothing to simplify. So we will start with, let me change the color here. All right, we will start by undoing. So we look at the variable x, it's being multiplied by 3 and added by 4, so we'll undo the addition first. So we'll subtract 4 from both sides. Okay, remember it's the additive inverse, so they did cancel. Last step, it's kind of like putting together lesson 1.1 in one equation. You'll have an addition, subtraction usually, and the multiplication, division, so you'll have to undo 2 different steps. So to undo multiplication, we divide by 3. And we'll get x is equal to 5, okay? And I would recommend going back into the original problem, and I will let you use some mental math skills here to simplify, so we maybe won't write as much on the checking. But just double check your math. You know, is 15 plus 4 equal to 19? And when you think it is, and you've tested it out, then you can say, yeah, I checked it. That makes sense. So in the end, you're pretty comfortable with that answer. Okay, for number 2, the first step we want to undo is the subtracting 13. So we have z being multiplied by 5 and then subtracted by 13. So we'll add the 13 to both sides. Remember to do our integer math, right? That equals 0, so bring down 5z. Now you're going to have a positive and a negative. We'll subtract, we get 10. The positive is the highest absolute value, so it's a positive 10. Undoing multiplication with division. And we get z is equal to 2. So again, let's do some quick checking here. Is 5 times 2 minus 13 equal to negative 3? And since 5 times 2 is 10, 10 minus 13 is negative 3, and it does check out. Okay, on number 5, we have some division mixed in. So we have f being divided by 4 and subtracted by 5. So let's do the subtracting by 5 first. So let's undo subtraction with addition on both sides. Okay, so we'll bring down our f divided by 4. And when we have a negative 9 plus 5, we know that we're going to have a negative 4. Okay. So now we have f divided by 4 is equal to negative 4. We're going to undo this division with multiplication. We're multiplying by the positive 4 on both sides. These cancel. And then we have negative 4 times 4, which is negative 16. And again, it's important to go back to the original problem. Negative 16 divided by 4 minus 5 needs to be equal to negative 9. And so that's negative 4 minus 5 equals negative 9, and that checks out. Okay? In number 6, because the whole expression of q plus the negative 5 is being divided by 3, we want to undo the division first. So look for things like this. Notice the difference between 5 and 6. 5, you have just the fraction f divided by 4, but in 6, the entire expression. So we have to kind of clear that 3 first. So this is the only time you want to start with the multiplication part. Okay? That will cancel. So we'll get q plus this negative 5 is equal to 24. So we're using the additive inverse, and we need this negative 5 to be a 0, so we have to add 5 to both sides. Okay, so q would be equal to 29. I have not been circling my answers to make it easier for you to find. I apologize for that. So now I can go back in and I can take 29 plus the negative 5, all divided by 3 has to equal 8. So now when I'm checking my work, I take the 29 plus the negative 5. That'll give me 24. 24 divided by 3 needs to equal 8, and it does. Okay, so take whatever time you need to copy these down before moving on. Okay, now you can see that we have jumped ahead, kind of skipping 7, 8, 9, and 10, 11, and 12. Of course, you're welcome to do those and try those out if you want to for extra examples or extra help if you need it. But now we're going to go into some examples that need a little bit more simplification before we can solve it. So since there's parentheses in both 13 and 14, we are going to need to simplify or clear the parentheses. The way to do that would be look at what's happening. So we have 33 equals 12r minus this 3 times what's in the parentheses. So we're going to have to distribute first. And I like to always kind of circle the number and the sign so that I know if I'm distributing a positive or a negative. It'll help me with my integers. So then I'll rewrite what I have. 33 is equal to, I get 12r. Negative 3 times 9 is negative 27. Notice how if I just write the integer down, the negative sign becomes the subtraction between the two numbers. Then don't forget r is also negative. So negative 3 times negative r is a positive 3r. We need to combine some like terms here. So I'll kind of circle the like terms. We get those two that are the same, and then this one is not. Remember, this is the equal sign right here. So we're still simplifying on the right-hand side, okay? So let's finish writing. So we've got 33, and now we'll combine our 12r and our 3r. These two can be combined to be equal to 15r, and then negative 27 is by itself. Now we're just in a two-step equation. R is being multiplied by 15 and subtracted by 27. So we would add 27 to both sides. Make sure it's the additive inverse. And I like to bring everything down. Here we're going to have 60 is equal to 15r. Now we're undoing multiplication. So we're dividing both sides by the coefficient of the variable. So 60 divided by 15 is 4. 4 is equal to r. And then go back to the original problem, not the simplified one, okay? Because if we're going to maybe we made a mistake in simplifying or distributing, so it's always best to go back to the original problem. So 12 times 4, and then minus 3, and then we have our 9 minus 4. So, oops. So here we can actually use some just PEMDAS and go ahead and simplify the parentheses first. So 33 needs to be equal to 48 minus the 3 times 5, so it's 48 minus 15, and that does equal 33. So we can say, yes, we checked it, it makes sense, we have the right answer. Okay, so number 14, we see that we want to distribute this positive 3. I always love positive numbers, don't you? You just have such a positive outlook on math. Okay, so 7 plus 6g, and then this is negative 6, so we have 3 times negative 6 is negative 18, and that's all going to equal negative 29. So the like terms in this case are the constants. So I go ahead and circle the constants, and then I can just put a box around here so I can just tell that they're different. That helps me distinguish the different like terms. So I can combine these two right here. So remember, when you have a positive and a negative, you want to go ahead and subtract them. So 18 minus 7 is 11, and it's going to be negative because the 18 is negative. So negative 11 plus 6g is equal to negative 29. Okay, now we just have a two-step equation. G is being multiplied by 6 and added by this negative 11. So we need to add 11 to both sides, the additive inverse. Okay. So bring down your 6g. Again, negative positive, we will be doing some subtracting. So we have negative 18. Negative 18. Now we're going to be dividing by 6. So g looks like it's equal to negative 3. Okay. Now I can test it out by going back to the original problem. 7 plus 3, and then I have this 2 times negative 3 minus 6 is equal to this negative 29. Notice how I changed my grouping symbols because I had 2 sets of parentheses there. So 7 plus 3, and then I'll have negative 6 minus 6. So it'll be negative 12. My numbers get a little sloppier. So 3 times negative 12, I have to have 7 plus this negative 36 has to be equal to negative 29. So basically, is 36 minus 7 29? It is. And since it's the negative, it's negative 29 equals negative 29, and it checks out. Okay? So make sure that you get that copied down. Okay, so now we're going to do number 15. You can represent an odd integer with the expression 2n plus 1, where n is the integer. So we're going to write and solve an equation to find 3 consecutive odd integers that have a sum of 63. So we need 3 consecutive odd integers. Now, I'm going to show you 2 different things. One, they told us we have to use this expression as basically this first integer, okay? So n is going to be the integer. So let's think about this. So when I'm doing an odd integer, so you can represent an odd integer with this expression. So we don't know what those 3 numbers are, right? We know that the first one is n, supposedly, or this expression 2n plus 1. And then we skip an even number and we go to the next odd number, and then we skip another even number and we go to the next odd number. And the sum of them is going to be 63. So when you're working with odd numbers, like if you have a number line here, let me just try to visualize this for you. And say this number is n, and we know that it is odd, okay? So if this is odd, this is going to be even, right? Oops. Then this next number is also odd, and how would we get there from n? We don't even know what n is, but if how many places away from n is it? 1, 2. So this one could be like n plus 2, okay? Then, we have this other even one, and then this one is again 2 spaces away from n plus 2, but it is 4 spaces away from n plus 1. And remember, these n's have to be the same number, the starting point. So I know this is sounding very confusing in this video, but this would be n plus 4. So that's the idea, right? And this would be the next odd integer. So it's kind of like saying n plus 2 plus n plus 4 equals 63. But they've kind of thrown a loop into it here. They have this n, our first integer, is equal to 2n plus 1, okay? All right, so that's equal to n. So think about that. So now when we go to this n plus 2, so then the second integer, so that's the first integer. How do I say that? First odd integer, okay? So now our second odd integer is going to be this 2n plus 1, because that's equal to n, but now we have to add 2 to it. So we get 2n plus 3. Our third odd integer is 2n plus 1, which is our n, and we have to add 4 to it because it's 4 places away from the first odd integer, so it's 2n plus 5. So now our expression is our first odd integer, and they made us use this expression, 2n plus 1 is equal to n, plus our second odd integer, 2n plus 3, plus our third odd integer to be equal to 63. So then we have some like terms that we can combine. We have all these n's, right, and all these constants to make an equation. Okay, so 2n plus 2n plus 2n is 6n. 1 plus 3 plus 5 is 9. And that's all equal to 63. So let's solve for n to see what it is, right? And then we know once we solve for n, we'll have to put it in right here to get the actual value of that number. So we'll subtract 9 from both sides. Okay, when we subtract 9, we've got 54. Okay, so then we could divide by 6, and we'll get n is equal to 9. So if n is equal to 9, 2 times 9 plus 1 is equal to 19, because that would be 18 plus 1. Okay, and then we would have 2 times 9 plus 3. Oh, goodness. See, these are the Kleinmanisms. You're probably like, why did you write an 8? All right, 18 plus 1 is 19. 18 plus 3 is 21. And 18 plus 5 is equal to 23. The real test will be, does 19 plus 21 plus 23 equal 63? Yes, it does. So we know that we've done it right. So our answers are, find 3 consecutive odd integers that have this sum. Here they are, 19, 21, and 23. Okay, so that one I know was a little bit tricky. If you need to maybe rewatch it 1 or 2 more times. The key to understanding odd integers, and the same is true about even integers too, when you have problems that are talking about consecutive odd or consecutive even, is that they skip every one place, okay? So, go ahead and take some time and think about any questions you might have about that one, and maybe we can work a few more odd or even integer problems in class, and we'll do one more example. Okay, this example I borrowed from the textbook, actually. It's not here in your journal. So I found room under number 17 on page 11. There's a blank space for problem number 17, I guess, the workspace. So let's go ahead, and in this case, just to refresh our memory on how do we solve for x and get the sum, of the angle measures and so forth. So we would want to list all the angle measures. So we know that we have 1, 2, 3, 4, 5, 6 angle measures that we need as an answer. 6 angles means 6 sides, which means this is a hexagon, and the sum of the total is 720. So I can start by writing an equation. X, and I can start anywhere, but just make sure you keep track of it, plus the 120 plus 100 plus 120 plus the expression x plus 10, that's that angle. I'm running out of room. Plus 120, is going to be equal to this 720, okay? So now it's time to combine like terms. So all the x's can get added together. Looks like there's just 2 of them. And then all of these constants, these numbers, and remember this one over to the right that's got cut off is 120. All right, so we can simplify this. So we have 2x, and then when you add 120 and 100 and 120, look what else I forgot. I forgot this one right here. Oops. And 10. Don't forget about this guy. All right. And 120. I got 450. So go ahead and add those all up. Make sure that I got the right answer. And that should equal 720. Okay, now we're down to a simpler two-step equation. So anytime you have a shape and you have the angles and you need to find the missing angle sums, you need to set up an equation like this and simplify. So we'll subtract 450 from both sides. 2x is equal to, and then 720 minus 450 is 270. And I'll divide by 2. And I'm going to get x is equal to 135. Okay, so now to list the angles, because I need all the angles. I have the original x, which is 135 degrees. I have the 120 that was given, the 100 that was given. Now don't forget about this guy right here. I have to do, oops, I have another 120. In the end, I was going to ask you to count them. So 135 plus 10 is 145, and then one more 120. So I have 1, 2, 3, 4, 5, 6. I know that I have all 6. The other thing you could do is add up all 6 of these numbers and these degrees to see if they equal 720, and then you'll be done. Okay, that concludes notes for lesson 1.2. So make sure that you write all of these down, and any questions that you may have, if we may need to discuss one or more of these examples and further before we begin working on our assignment.